Okay. I'm David. I'm coordinator of the Maths Learning Centre. This is a revision seminar for Maths 1A. It's Semester 1, 2016. Hello to those listening to me in the future from the past. I'm going to start off by talking about slack variables, which is really under the part of the course which is called optimisation and convex sets. So optimisation with slack variables. Okay. Slack variables are a very clever idea. Whoever thought of them, I don't know who, had a very wonderful inspiration the day that they came up with this, because it's a way of solving problems which already have 2 or 3 variables by making them have even more variables, which you think would make it harder, but actually it makes it easier. Well, in the sense that possible is easier than impossible, and so I'm going to try and get a handle on what the slack variables are, and then that's the philosophy. And it's all great to have philosophy and to know what things are, but sometimes what it means is that you still don't know how to use them in practice, so I'll talk about that too, because they're separate skills. And I would recommend any time you learn anything to try and separate those two ideas and make sure that you know what things are, and also that you know how to deal with them, because they're not always exactly the same thing. Okay, best to talk about with an example. So, here's my example, and I'm not going to do one of the ones at the moment where you turn inverted commas real life problem into equations. I'm just going to start with the equations first. I've already written e.g. Doing well. Max. Two x plus 3y. Subject to. No squares. It's linear optimization. I'm just imagining what this looks like so that I can figure out the other constraint. Hopefully this isn't too horrifying. Okay, so this is your traditional optimization problem that can be solved with slack variables. Okay, we want to find the maximum value of something, and this thing is linear, meaning that I don't have any x squareds or y squareds. It's just constant multiple times x and or a constant multiple times y. The theory of how this works only works if that's linear. And then you have a couple of linear inequalities, possibly linear equations, and then also finally you round it off with x and y both have to be positive. And the reason this is so is because this theory will only work if everything's linear. Okay. So, the theory goes that linear inequalities will specify a convex set. They must specify a convex set, and that if you have a linear function specified on a convex set, then the maximum or minimum has to happen at one of the vertices of the convex set. So what we need to do is we need to find the vertices of the convex set. Great. We could draw the set and it would tell us where the vertices are. The point of slack variables is to not draw the set, but I will do it anyway because it will help you understand what's going on. Yep?
So in the exam question they asked for algebraic method, this is what we're doing, right?
Yep, this is the algebraic method. But I'm going to draw the set as well. I will thank you for pointing that out. I will draw some boxes around things and say this is the algebraic method and this is the graphical method. So first I'm going to show you what the graphical method looks like. There's my x and y axes. And I will draw all of these lines. So there are in fact 4 lines here. When each of these is equals, it's a line. So 5x plus 2y is equal to 20, that's a line. And 3x minus y is equal to 6, that's a line. X equals 0, that's a line. Y is equal to 0, that's a line. And I have 4 lines defining the edges of my convex set. So x equals 0 is the y-axis, because all those points line up with 0 on the x-axis. Y equals 0 is all the points that line up with 0 on the y-axis, which is the x-axis. 5x plus 2y is less than or equal to 20 is a line, and I can draw it by drawing in its x-intercept and its y-intercept. So when x is 0, the y-intercept is 2y equals 20, so y equals 10. Okay, and when y is 0, the x-intercept is 5x equals 20, so x equals 4. Not drawn to scale, but, you know, doing okay. And this line here joins up those 2 points. So there is no particular reason why you should rearrange it to get y equals if you don't want to, because you can just find the x and y intercepts by subbing in x equals 0 and y equals 0. I'm calling it 1 so I can label my lines on my graph. Okay, and the other line is 3x minus y equals 6. So when x is 0, y equals minus 6, which is down here. And when y is 0, x is equal to 2, which is here. And so that's this line here. Line number 2. Now, that's what it would be if everything was equals. Okay, so there's no points that satisfy all 4 of those equations at once. But the inequality says that actually any point that I sub it in there, and where 5 times the x coordinate plus 2 times the y coordinate comes out to be less than 20, is a perfectly acceptable point that's part of my set. And so what's going to happen is the entire side, one side of the line, all of those points are going to be in the set, and the other side of the line, all the points are going to be outside the set, and I just need to know which side is which. Okay, so what I normally do when I do that is I draw a different diagram and I cross out the bits I don't want. So I pick a point that's not on the line, and I know that if that point, when I put it into the inequality, if it comes out true, then that's the correct side of the line, and if it comes out false, then that's the wrong side of the line. So the point 0, 0 is a really helpful point, which is not on line number 1, and when I sub it into the inequality for line number 1, 5 times 0 plus 2 times 0 is 0, which is indeed less than 20, so 0, 0 is on the correct side of this line, so I don't want this bit, because it's on the wrong side of the line, because 0, 0 is on the right side. And 0, 0, when I put it into this equation, 0 minus 0 is indeed less than 6, and so 0, 0 is on the correct side of this line too. And so this is the wrong side here, the one that doesn't have 0, 0 on it. And I also need x to be greater than 0. Well, down here, over here is where x is negative, so I'll cross that bit out. And y to be greater than 0, so down here is where y is negative. So the bit that I have left, that's my set, that bit there. And you see, if I put that other bit on a piece of scrap paper and didn't show anyone, I would look so clever. Because I could just colour in the bit I wanted. But I find it much easier to just cross out the bit you don't want. Because if you cross it out twice, you just still don't want it, right? So it's fine to cross it out 3 or 4 times. Okay, so here's the thing. I know that this little kite shape here is the region which satisfies this. So you know, I could sub in any point into this formula and it would give me an answer, and I could sub in like 10, 10, which is here, and it would give me an answer, but I don't care about that point, I only care about these points. And I know that all of the points in this little zone, they'll all give me different answers, but the ones at the corners will give me the maximums and minimums. They won't all be maximums and minimums, but one of them will be the maximum and one of them will be the minimum. It could be that multiple of them have the same maximum or the same minimum. Really, I just need to figure out what those 4 points are, and 2, 0, and 0, 10. I just need to figure out what that point there is. And this point is when I get the intersection of line number 1, which is when 5x plus 2y is 20, and line number 2, which is when 3x minus y is 6. And I could solve those two equations simultaneously, possibly using a matrix. What's the point of learning matrices if you're not going to use them? And that would tell me what this point here is. Right. That's great. That's the graphical method. Okay? I will figure out what all of these points are, and I'll sub them all into here, and whichever of them is the maximum is the maximum. You can actually be a little cleverer, and you can draw lines with this slope. 2x plus 3y is equal to 0. There's like a line with the right slope where all the points give the answer 0. And when 2x plus 3y equals, say, 6, that would be 2x plus 3y equals 6 would be x is 3, y is 2. So like that. And that's where the answer is 6. And this is where the answer is 10. This is where the answer is 12. Or whatever it is. So as this line moves up, all the points along this line have the same value p, and the value p gets getting bigger and bigger. And so the last point in the set that it hits is that one there, so the maximum must be there. So you don't actually need to find the coordinates of this point, because this equation here tells me that the maximum has to be there, because that's the last point that a line of slope 2x plus 3y hits. Brilliant! So I don't even need to find this point if I do it graphically. I'm just going to draw that in if I can find a straight enough edge. Not that any of the other stuff was straight, but whatever. I'd like to pick a number that both of these go into, 2x plus 3y equals 6. So then the x-coordinate, x intercepts 3 and the y-coordinates intercept 2. That's where p equals 6. And then a bit higher up, p would be a higher number. And so the last point that any line of this slope hits is that point there. And so that's where the maximum is. And I would actually say that this is increasing p. So when I move the line that way, p increases, and so there you go. And so actually the maximum is at 0, 10, and so p at that point is 2 times 0 plus 3 times 10, which is 30. Okay, that's the graphical method, which is great, especially good if you've only got 2 variables, x and y. If I had 3 variables, that would be a whole different story. Okay. I'm just going to put a note here. This is finding the feasible region. Okay, now let me talk about slack variables. Oh, I should point out that if your lines are not quite so nicely different in slope, you would have to draw it way more accurately than I did. This slope here was quite steep relative to that one, but if they were a bit closer together, I might have to be a bit more precise about where things were, because maybe it would hit this other point here last if the slopes were different. If my line was more like... No, actually that would be pretty good. If it was more this way, then I might have a problem if things were lined up wrong anyway. If it was coming down this way, yeah, if the slope was more like that, then the last point it hits would be that one. So just be careful that your slopes are done correctly. Okay, slack variables are a way of not having to do that, because of course there's that problem of not drawing your diagram accurately. I'm going to redraw my diagram so I can tell you what the slack variables are. Okay. Right. It's very, very clever. Oh, I'm just going to label my lines. This is line number 1 and this is line number 2. Okay. Right. I need my x's to be positive. My x's are positive over here, and my x's are negative over here. So the x value of my point, the x coordinate, tells me whether I am on the correct side of the y-axis. So this line here, the y-axis, tells me when... Oh, crap. That's where x equals 0, on the y-axis itself. And over this side is where x is positive, and over this side is where x is negative. I mean, that's like, well, oh, duh, David, but anyway, getting there. And down here, the x-axis does the same thing. On the x-axis is where y is equal to 0, and up here is where y is positive, and down here is where y is negative. What I want is a similar sort of thing for each of the other lines. This line, which is on the edge of my set, I have a number, a variable that tells me whether I'm on the line, and I have a number that tells me whether I'm on which side of the line I'm on. And note that where y is positive, that's the correct side for where my set is. My set is on this side. And where x is positive, that's the correct side for where my set is. So what I want is a number that tells me what all of those for the other lines. I'm going to get another variable which will tell me whether I'm on line number 1. And I will call it slack variable number 1. Slack variable number 1 will be 0 when I'm on line number 1. It will be positive when I'm on the correct side of the line for where my set is, and it will be negative when I'm on the wrong side of the line for where my set is. And line number 2 will have its own variable as well. Slack variable number 2 will be equal when I'm on the line. It will be negative when I'm on the wrong side of the line for where my set is, and it will be positive when I'm on the correct side of the line for where my set is. So what my slack variables do is they tell me where I am in relation to each of the lines. And so for every point I can now add 2 extra variables, one for each of the lines that tells me which side of each line I'm on, whether I'm on the good side or the bad side. And I want it to be positive when I'm on the good side of the line and negative when I'm on the bad side of the line. Right. Now, how are we going to do that? Well, line number 2, or maybe line number 1, had this equation here. Every point on the line, 5x plus 2y is equal to 20. Every point on the good side of the line, 5x plus 2y is properly less than 20. And every point on the bad side of the line, 5x plus 2y is more than 20. And so what I can do is I can make a variable to say how far away from 20 it is. Because if I'm less than 20, I can have a positive number that tells me how far I go to get up to 20. And if I'm more than 20, I'll get a negative number which tells me how far down to go to get to 20. And so that's what my slack variable is. It's how far away from this number I am when I sub in the point into this formula. So what I'm going to do is I'm going to say that slack variable number 1 makes up 5x plus 2y up to 20. So that 5x plus 2y plus a bit left over is 20. And what that will mean is that when S1 is 0, I'll get 5x plus 2y equals 20, which is on the line. When x1 is properly positive, the 5x plus 2y doesn't make it all the way to 20, and so it's less than 20, which is the good side. And when x1 is negative, well then 5x plus 2y would have to be bigger than 20 for that to happen, and that would be on the wrong side of the line. And so that's why it's called a slack variable, because it picks up the slack, in the sense of picking up someone else's slack when you're in a group project and they're not doing any work, right? So that's the idea behind it. I mean, in the literal sense of having a rope that's lying slack and you pull it until that it's tight, but you know, the other one's funnier. So S2 makes up 3x minus y is less than, we've got a 6, you know, up to 6. That's why when you do this, you have to flip it to be less than or equal to when you put your slack variable in, because you need it to go up to that point. So it has to be less than. If it was greater than, you'd need it to be negative, because it has to be positive on the correct side of the line. So now we have that every point has its actual coordinates, x and y, and also it has these new numbers, S1 and S2, which tell you how far you are from the total you're expecting. And now we have 4 variables and 2 equations. So we can't figure out what all of the variables are, but this is the other really clever bit. Vertices here are on 2 of the lines at a time. You know, these are lines, and when you have 2 lines, they meet and they make a point. So this point here is on this line, and this point here is on this line and this line. And when 2 lines meet, you make a point. But to be on this line, S1 has to be 0, and to be on this line, y has to be 0. So this gets 2 of my variables equal to 0. And to be on this line, S2 has to be 0, and to be on this line, S1 has to be 0. So that point is where 2 of my variables are 0. And this point, 2 of my variables are 0, and this point, 2 of my variables are 0, and this point, 2 of my variables are 0, and this point, 2 of my variables are 0. And in fact, there are 6 points which you can make by joining 2 lines, and that comes in pairs of which variables are 0. That's the really clever thing. You're going to go, just a second, I'll make some of the variables 0, and I'll figure out what those points are. Only, that would take you forever, well, you know, 6 times however long it takes to do the equations. And so instead of focusing on the ones that are 0, well, the ones that aren't 0 will tell you the coordinates at that point. So what we're going to do is we're going to figure out all the pairs of ones that aren't 0. And that's how you do slack variables. And that's why you do slack variables. I hope that makes sense. So I'm just going to do something. Whoa, that way. Oop. Good, good, good. If I was in 3... Good-o. I didn't know what I needed, so I brought lots of stuff. Okay, if I was in 3D, maybe this line would be my x-axis, and this would be my y-axis, and this would be my z-axis. And so this bit over here is the part of the feasible region, because x and y and z are all positive. So what I might have is the equation, a linear equation, x plus y minus z equals 0, for example, equals 5, for example, would be a plane. And that plane would slice into here and produce a little region underneath it. And I'd cross out this bit and I'd have that bit down there. And then maybe there'd be another plane which would slice in here maybe and produce another region in there that meets this in a different way. I don't, you know, I could cut this, I suppose, but I can't be bothered. So the point being that the planes now slice space into a region. And to get a point, you need 3 planes. This point down here is where this plane and that plane meet. 3 planes meet in a point. So I'll need 3 of the variables to be 0. There's a variable down here, that's when z is 0 on that plane down there. And this plane over here is when y is equal to 0. No, x equals 0. And this plane is where slack variable number 1 is 0. And though 3 all being 0 would be that point there, where all 3 of them are 0 at once. I just needed to rectify something in a previous seminar where I did all that without having video of it. I don't know if it's any better with the video, but I feel better. Right. So I'm just pointing out that you can do it in 3D, and one could conceivably draw a diagram in 3D. It would just have to be a box construction. Play school, eat your heart out. So, right, back to here. What we're going to do is we're going to arrange to get 2 of the variables 0 at a time. I've separated them that way deliberately because this variable, conceivably this equation conceivably could have had an S1. It just doesn't, because that doesn't make any sense. But, I have 4 variables. And each variable has a coefficient, and there's also an answers column, 5, 2, 1 S1, no S2s, and 20, 3, minus 1, no S1s, and 1 S2 is 6. And that is my lovely little augmented matrix. So I can imagine going, all right, well, I want to figure out what happens at the point 0, 0. That's when x and y are both 0. And that's telling me that S1 is 20 and S2 is 6. I could try and figure out what happens at the intersection, maybe this point just here, which is when S1 is 0 and when y is 0. That's this. And I would have to solve that equation. 5x equals 20 and 3x plus S2 equals 6. And I could solve that and it would tell me what x1 and S2 would have to be at that point. Now the x1 would tell me the x-coordinate of that point, and the S2 will tell me whether I'm on the correct side of the line or not. It turns out, let's see, if the S2 is going to come out to be negative, which means that I'm on the wrong side of the line. Okay. That's the idea behind it. I'm going to set various of them to be equal to 0 and figure out what the other variables would have to be. But that's too hard. Instead, what I'm going to do is say, well, if I was going to figure out what these 2 columns came out to, what I would need to do is I'd need to do row operations to create a little identity matrix here, and that would tell me what they were. So instead of focusing on which ones are 0, I'll focus on which ones make an identity matrix. The whole point now, so let's just step back a bit. We've added slack variables to each of our inequalities because we know that that tells me whether I'm on the lines or not. And we know that if we just look for the biggest identity matrix we can fit into this matrix here and get them in all the possible places where the identity matrix could be, then it will tell me where the vertices are. It will tell me all the vertices, not just the ones inside the set, but then I can look closer to see whether they're inside the set, because I know that being on the correct side of each line is the same as these variables all being positive. So that's why it's such a clever idea. I have no idea who came up with it, but it's so cool. It's a really clever idea. Right, here we go. So I'm just going to make another list for myself of the things that could happen. So a list of the possibilities. I have 4 variables, x, y, s1 and s2. And I know that I want to make some of them have the identity matrix and some of them have zeros. So I'm going to just be systematic about it. I could have x and y being my identity matrix and the other 2 being 0. X and S1 being my identity matrix and the other 2 having 0. X and S2 being my identity matrix and the other 2 having 0. And now that's all the ones that have x in them. I've got x and each of the other ones. So I'll move on to y. Y and S1 and the other 2 are 0. Y and S2 and the other 2 are 0. And now that's all the ones with y, because I've already covered the ones with y and x. And so I'll move on to the next variable, S1 and S2, and the other two are 0. And I can't go any further along. So what I've done is I have moved my way along. I've started with the two first ones and then moved this one. And then I moved this finger and then did the other two, and then I moved this finger and did the other one. So I'm being systematic about it, having one of them and moving the other, and then moving that first one along, and then moving the other, and then moving the first one along, and then moving the other. And now I have all of the possibilities. This is what I'm going to get. I'm going to have to fill in those empty boxes with numbers at some point, but that's what I'm going to get. And just to check that I have the right number of them, 1, 2, 3, 4, 5, 6, I'm going to count how many ways there are to choose 2 out of 4. 2 to be where my identity matrix is. So let's see. 6, choose 2. Not 6. Damn, 6 is the answer. 4, choose 2. You may have seen this as 4, choose 2, if you like. Your calculator calls it that usually. And the way to calculate anything, choose anything, well, is to do the bottom number and go start it and go down to 1. And then do the top number and go down as far as you need to go to match the bottom number. So I've got 2 on the bottom, so I'll go 2 times 1. And then my top number, 4 times 3, I'll keep going down until there's the same number of the ones as there are on the bottom. So if it was 4 choose 3, I would have had 3 times 2 times 1 on the bottom, and the top would have had 4 times 3 times 2. They always have the same number. And so I get 6 as my answer. So I was supposed to have 6 possibilities, and yes, I have 6 possibilities. That's just a way of checking that I have the right number of rows in my table. In case you have a calculator like this one, it's usually got a button of its own. It's just here. See? NCR. Just there. And that's the shift. So I'd go 4, shift, NCR 2, 4C2 is 6. My calculator agrees with me.
Sorry, Dave.
Yep.
Can you explain what the 4 and 2 means?
The 4 is how many columns I had to choose from here.
Yeah.
And the 2 is how many spaces I want to put my identity matrix in. Because I'm going to choose out of those 4 columns, I'm going to choose 2 out of 4 columns to put an identity matrix in. I'll do another half example later to illustrate this point. So, you know, some people say that the 4 is the number of original variables plus the number of inequalities. Look, I don't care. Once you put all your slack variables in, just count how many variables you've got, and then count how many rows there are, which is, you know, you fit the biggest identity matrix you can. You're trying to choose which columns you're going to put your identity matrix in. Okay, so here we go. I already have one. There's an identity matrix here in column S1 and S2. And so if X is... So the other two where there isn't an identity matrix are 0. S1 is 20. So let's look at that. I've got an identity matrix in S1 and S2. X is 0 and Y is 0. That's this row. S1 is 20. S2 is 6. I have my first solution. It's feasible because everything's positive. It's on the x-axis. It's on the y-axis. It's on the x-axis. It's on line number 1. It's on the correct side of line number 1. It's on the correct side of line number 2. And the actual coordinates of the point are the x and y coordinates that we started with. This is the point 0, 0. That point just there. Its x coordinate is 0, its y coordinate is 0. It's on the correct side of line number 2 and the correct side of line number 1. So I've got this one. My goal is to now do 5 row operations. I don't want to do any more than that. Well, 5 pivots. I might have to do 10 row operations to get all the other possibilities. So let's see. I could put I need to make an identity matrix, a 1, 0 and a 0, 1. It doesn't matter what order they're in, they can be the wrong way round, it'll be okay. So I would like there to be, say, for example, a 1 here. And that would give me, if I had 1, 0 here and 1 there and 0 there, then I'd have y and s1. So I'm going to make that 1 minus 1. Like that. That was row 2 is minus row 2. And then I'll make a 0 here. Okay, so I didn't change this row. Ooh, not 31. And we'll take off 2 of these. So 5 minus 2 times minus 3 would be 5 plus 6, which is 11. That's a 0. So 1 plus 2. And I get this answer here. So look, I've got an identity matrix. It's the wrong way around, but it doesn't matter. My identity matrix here is in column Y and column S1, and the other 2 columns are 0. And so I've got that Y, because that's where the 1 is minus 6. And S1 is 32. So this point is on the y-axis. It's on line S2. It's on the wrong side of the x-axis, and it's on the correct side of line S1. That's this point here. There. Its x-coordinate is 0, its y-coordinate is minus 6. That's this point here. And I'll just continue until I've found them all. Yay! There is a work example that goes through the whole thing, so maybe I will shortcut that now. Do you want me to do the whole thing? Got some shakes. Good. So that's what I'll do. I'll just continually keep filling them in. I will at least try and do the x and the y, because that will tell me this point here. I will do that one at least. So let me put a pivot just here. Minus 3, 1, 0, minus 1, minus 6, 1, 0, and 11th, 2 11ths, 32 over 11. Awesome. And row 2 is row 2 plus 3 of row 1. Three times 2 11ths would be 6 11ths. 6 11ths minus 1 would be minus 5 11ths. Two times 3, 96 over 11. Oh no, we're adding it, aren't we? Yeah, that's okay. Apparently, I could have that wrong. It should be 3 times 32 over 11 minus 6. Yep, okay. So, I've done this one because this is telling me that the x is 32 over 11, the y is 30 over 11, and the other 2 columns are 0 because there's no identity matrix columns there. So when I go back to my original thing here, this one's 32 over 11, this one's 30 over 11, and the other 2 are 0. And all the other ones are actually already listed on my thing. So I've got y is 0, and I'm on line S2, so this one's... I don't know what S1 is yet. Well, I can tell that. 2 times 0, just bear with me, I'm just figuring things out. 10, so this is a 10. Oh gosh, minus 30. Okay, just so that it all looks filled in, don't do that, do it properly. Though to be fair, you know, a lecturer could ask you that. I was able to figure out those things here, like this point here, 2, 0. I can sub in 2, 0 to figure out what slack variable number 1 is, because if x is 2 and y is 0, I've got slack variable 1, 10 plus slack variable 1 number 1 is 20, so slack variable number 1 is 10. You don't normally need to know what the slack variables are, but I needed to do it so that I could point out the next part of the process. When I look at these, I can tell which ones are feasible because they're the ones that are all positive or 0. They're positive, that one's negative. If any one of them's negative, it's not feasible. That one's negative. And so I get 4 feasible solutions, and I can just pick out the x and y coordinates. The only reason to have the slack variables was to tell whether they were part of the set or not, and so I can now ignore them, and so I've got the vertices are 32 over 11, 30 over 11, 2, 0, 4, 0, and 0, 10. Right. I just read off the first 2 coordinates of those points. And then I would have to sub all those points in to the P formula to see which of them actually gave you the maximum. P equals... So let's see. What was P? 2x plus 3y. 2... Haha! It's cool. Sorry. Comes out to a whole number. What are the chances? Okay. So when I sub them all into the formula, 2 times x plus 3 times y, I get these answers, and that's the maximum there. Yep?
Is there a less labour-intensive way of doing slack variables?
No. There is not a less labour-intensive way of doing slack variables. Yes? Oh, Frel. You're right. 0, 0 is the other one. I knew I'd done something wrong. Thank you. Zero, zero, that one. Thank you. Right, so the question was, is there a less labour-intensive way of doing slack variables? Well, no, but you could teach a computer to do it.
I was thinking for an exam.
So if you're in an exam, almost always the people writing the exam will only ask you to do a couple. They won't ask you to do all of them. Or they'll give you a partially completed one and get you to finish it off. So they'll say, we've already got all of these ones, what's the last one? Or they'll say, here's, you know, set up your original matrix, tell me the first solution you see. And you can go, aha, I've already got an identity matrix, there's the first solution. Okay, so that's what they'll do. They'll only get you to do a couple of them if it's in an exam. I do want to point something else out. Whenever you see an example of anything, you should always ask yourself, well, what would happen if, such as what would happen in the exam, but also what would happen if there were 3 rows? What would happen if there were 3 variables or 3 equations? So I just want to do a couple of what would happen ifs and not finish them off, but just point them out. What if you had, you know, x, y, z as your original variables, and you ended up with 2 slack variables. Okay? In that case, you'd end up with something like this. So maybe you get 2 inequalities. So that would look something like this. So it might have something like that. That would end up looking like this. Okay, because each equation would get each inequality would get a slack variable, and that would turn into equations, and each would be a row, and you'd get something like that. And now we've got 5 columns because we had 3 original variables and 2 slack variables. And we have to pick the biggest identity matrix I can possibly fit into those columns is a 2 by 2. And so I need to pick 2 out of those 5 columns to be identity matrices. Must pick 2 out of 5 cols to put the 2 by 2 identity. So the number of combinations I'd be expecting to get so the possibilities will be 5 columns, pick 2. I mean, it's literally 5, choose 2. I'm choosing 2 things out of 5 things, which would be 2 times 1 and 5 times 4, which would be 10. And they would literally look like this. So I'd go x is 0, x and y and z could be, well, x and y could be my identity matrix, and there'd be zeros here, x and z, and there'd be zeros here, x and s1, and there'd be zeros here, x and s2, and there'd be zeros here. That's all the ones with x. I'd have y and z, y and s1, y and s2. Cool, that's all of the ones with y. Z and S1, Z and S2, oh, 1 to go, and S1 and S2. And let's just check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I have the correct number. That's the idea behind what you would need to do. Now an exam, as I say, they'll only do a couple of them. But they will definitely ask you this sort of question: how many feasible solutions would you, not feasible, how many basic solutions would you expect? That's what this is here.
And for that, would you have to show the working, or could you just plug it into your calculator?
You could plug it into calculator. Once you know the formula, it's quicker to just do it than to find the NCR button on the calculator. And just one more what if. What if we had something like this? What if one of them was an equation and not an inequality? Well, you only have to add slack variables to the ones that have inequality signs. You don't have to add it to the equation. So I'd end up with x plus y minus 3z plus slack variable number 1 equals 0, and 2x plus 5z plus slack variable number 2 equals 8. Sorry? Oh yes, I should need to switch them round. Thank you very much. I need this to be less than or equal to. Damn. Because otherwise my slack variables will be making it down to 8 and not making it up to minus 8. And then I still have this other equation. It's still there. And so what I'm going to end up with (1, 1 minus 3) and 1, 1 is that. Oh, sorry, that was bad. Like that. And let's look at this. I have 5 columns in which I can put an identity matrix, and the identity matrix I will fit will be a 3 by 3. So I'm going to need to choose 3 columns out of those 5 to be my identity matrix. Three columns out of 5 to be identity matrix of a 3 by 3. And so, number of possibilities equals 5 choose 3 times 2 times 1, 5 times 4 times 3, which is 10 again. Just pointing out that it's about choosing how big an identity matrix you can fit. But this time I'd need to be systematic, and I'd have XYZ and then XYS1 and then XYS2, and then that's all the ones with XY, and then I'd have, you know, so it just, that's the reason to calculate this, so that you know when you've got them all. Alright, there you go, that's slack variables. I really hope that helps whoever asked and everyone else as well. Do you have any questions about that before I turn off the recording and talk about something else? Alright. Just let me say that when you do have an equation like that, what you're actually doing is the equation represents a plane, and then what happens is that you're actually looking just inside that plane. The other 2 equations will slice the plane up into pieces, and you'll just be drawing things on the plane itself. And you'll get a feasible region inside the plane. That's why you only need 2 slack variables, because you only need to know what side of it is inside the plane. So, there you go.